All right. Algebra 1 notes. Algebra 1 notes. This is section 8.3. Graphing parabolas, which we have been doing. We're just going to add something to it. Graphing parabolas, they're going to look like this. F of x equals ax squared plus bx plus c. So this is the a value that we talked about the first lesson. And this is the b value. So these aren't, you're not going to actually see these letters a, b, and c. They're going to be numbers. And this is going to be the y-intercept or the constant. So we'll talk about all this. Make sure you put your name, date, period on the paper. Okay, take some good notes. Okay, you might do this on graph paper. It'd be worth it right now to start over with graph paper if you want, because there's gonna be a bunch of graphs and it's just it's quicker and easier. Looks nicer on graph paper. I'm gonna fake it and just do it without graph paper, but it's a lot quicker with graph paper. Okay, so let's talk about the big ideas. So I'm gonna use just the left side over here. Axis of symmetry, which we've been talking about. You're gonna be asked to find it, but we're gonna use a new formula. The formula is x equals negative b over 2a. Negative b over 2a. So this is the formula for the axis of symmetry. The vertex, which we've talked about, it's like that highest or lowest point where it turns around. We're going to get the vertex by substitute this value of x back into our equation. Okay. So we're going to plug it in there to get the y value. So find the y coordinate. Okay, number 3, we are going to find the y-intercept, which should be pretty easy because it's just whatever the c value is. So no work for that. Number 4, we're going to decide if it opens up or down. If it opens up if a is positive. So if that number in front of the x squared is positive, then it opens up and it looks like this. Looks like a smiley face right there. This is your vertex, which is a minimum because it's the lowest point on the graph. It opens down if a is negative. Okay, and so if it opens down, it's like this. It's going down, and the vertex up here at the top is the maximum, the highest point on the graph. And another strategy is that we could factor, and we did this, I think, in our last lesson, factor to find the x-intercepts. So the x-intercepts are the roots, the zeros. So this is sort of this is what we're going to be doing on each of the problems today in our notes. Okay. Now I'm going to do the first example over here. So example 1. The directions are graph the following, label the vertex and axis of symmetry. Okay, label the vertex and axis of symmetry. So the equation given in standard form, so standard form looks like this. Standard form y equals x squared minus 4x plus 4. So this is standard form with the x squared term first, and the x term, and then the constant term. The first thing we should do is write down what the a, b, and c values are. So that the a value is in front right here. If you don't see anything, that's a 1. If that whole term is gone, it'd be 0. B equals -4. And c equals +4. So if there's a minus in front, that belongs to that number. So that's our a, b, and c value. And we're going to use that to find a lot of things. So I'm gonna draw my graph over here. I'm gonna leave some room right here to do work. But this is where graph paper would help, because I got to make my axis extra dark, because it's going to be hard to tell. If you're on graph paper, then you just have all the grid lines already there, and you just draw your x and y axis on top. But I'm going to actually create my own grid lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess you could get a ruler. It'd be a lot more work, but it'd look nice. But I'm pretty good at drawing straight lines quickly. They still don't look great. Graph paper would be way easier. Okay, so there's my my grid. So we're going to start. We're going to find the axis of symmetry first. And so over here, I showed you guys there's this formula, x equals -b over 2a, which might be good to just rewrite it down just to have it in front of you. It'll help you remember it. And so x equals negative, the b value is -4. I put everything in parentheses when you plug them in. When you substitute these values in, put them in parentheses, okay? And then that's going to be +4 over 2, and that's going to be 2. So the axis symmetry is x equals 2. Now, I'm going to draw the axis symmetry with a different color just to make it stand out. I think it'll be helpful. Usually make it dashed. And if you're doing it on graph paper, then you don't have to make it like super dark and thing. You just want it to stand out. You put arrows on the ends, okay? Because that means it goes on forever. You need to have arrows on the ends of your axis, you need to label your axis X and Y, because they look like the axis. So we got that. The vertex. Well, the vertex, what we do is we plug this value into the equation. So we say, we could actually write it like this. We could say f of 2 equals 2 squared minus 4 times 2 plus 4. So I just plugged this 2 that we got from the axis symmetry in for all the x's. I put it in parentheses, and then we got a full order of operations. The 2 squared is 4. 4 times 2 is 8. Plus 4. You can't do 4 minus 4 is 0 because you're doing subtraction before multiplication, PEMDAS. Now, that's going to be -4 plus 4 is 0. So that's the y value of the vertex. That's the x value of the vertex. The vertex is a point. It is 2, 0. On your graph, 2, 0, 2, 0, right here. That's your vertex. Okay? All right. Okay, so the next thing we're going to do is we're going to find the y-intercept. Now, the y-intercept is easy because it's just the c value up here. It is 4. And so the y-intercept would be on the y-axis. 1, 2, 3, 4 would be right here. So that's the y-intercept. Okay? Now, we need another point to make this graph. Now, if we have a point, the parabolas, they have the same shape on both sides. So if you look, okay, well, there's a point here and it's 2 away. If we go 2 over here, we get another point. Like it gets flipped over that. We call that the mirror image. Okay, now we have enough points. We got 3 points. So we could graph this. We connect the dots with a nice smooth curve, not a V, but a nice smooth curve. We should put arrows on the ends. Okay, so we got our graph. There's a couple more things we need to find. The domain. Now the domain is all the x values that you could plug in. Now we can keep plugging x values left and right forever, so that'd be all real numbers. Now, a shortcut for all real numbers is write this. It looks like a capital R with two vertical lines. Okay, so that's the domain. The range is the y values. Now, the range is usually not real numbers. If you look here, the y values start at 0 and they go up. So y is greater than or equal to 0. That's your range. And then we have the minimum or maximum. Is it a minimum or is it a maximum? Now, if you look at the picture here, it's down here at the bottom. That's a minimum. That's the bottom. And they might ask you what is the minimum value? And it would be the y value of that, which is 0. So the minimum value is 0. Okay. So that's what we're doing on each of these. Okay. Now, we're going to just try a couple more examples. So let's see. Let's try example 2. The instructions are going to be the same. Graph the following. Label the vertex and axis of symmetry. Okay. And the standard form is going to be given to us. The standard form is this time y equals negative 3x squared plus 6, which is a little weird because it only has 2 terms. But that's okay. And I'm going to draw my graph real quick. If you have graph paper, then this should be a lot quicker for you and look way nicer. But I'm just going to go and fake it. I don't have any graph paper at home right now. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now, first thing we should do is figure out what the a, b, and c values are. So this is in front of the x squared term. That's your a value, negative 3. B is in front of the x term, which there is no x term, which means b is 0. B isn't 1. Like if there was no number in front of x squared, that would make a equal to 1. But because there is no x's, there are 0 x's, then the b value is 0. The c value is 6. So we need those. So this is kind of weird because b value is 0. So we're going to start with the axis of symmetry. And the formula is x equals negative b over 2a. So negative b is 0, put it in parentheses, over 2 times a is negative 3. Negative 0 is just 0. Over negative 6 is 0 divided by anything is 0. So the axis of symmetry is x equals 0. Now, you should include the x because it's a vertical line. Any vertical line has the equation x equals number because all the x values are the same. I'm going to use something different. Now, this one's kind of hard because it's right on top of the y-axis. Okay, so kind of try and make it stand out a little bit. You could use a highlighter if you want instead. So that's the axis symmetry. Okay, next step to find the vertex is we plug that into the function. So we plug that in up here, negative 3 parentheses 0 squared plus 6. Well, 0 squared is 0 times negative 3 is 0 plus 6 is 6. The vertex, the x value is 0. The y value is 6. So 0, 6. 1, 2, 3, 4, 5, 6. Here's the vertex. Okay. And then the next thing we do is we find the y-intercept. Now the y-intercept is easy. It's just c value, which is 6. Which, by the way, we already have on our graph because the vertex is on the x-axis. So we already have the y-intercept. Okay, now here's a problem. We need like 3 points to make this graph. And last time, the y-intercept with its mirror image got us there. But we don't this time, so there's a couple things we could do. We could try and find the x-intercepts if they come out nice, but they might not. This time they wouldn't. We could just plug another value in, like we're doing a table. So we go, oh, let's just plug 1 in. Negative 3 times 1 squared plus 6 is negative 3 plus 6 is 3. So we have another point, 1 comma 3, like a table, right? Like a function table. So 1, 3, go right 1, up 3. So that's our table value. And then you could do a mirror image to the other side to get a quick another point. You don't have to do a table to get that other point because you know that these parabolas have this kind of mirror. You know, the left half looks just like the right half. Put some arrows on the ends. Now we got a couple more questions to answer about this guy. We got the domain, which is all reals again. We got the range, which is y is less than or equal to 6. Less than or equal to 6. We have the max, the minimum, or maximum. Is the vertex the highest point or lowest point? Maximum, highest point. What is the value of 6? So there we go. Let's do one more. One more. And then we got, and then I think we'll have the hang of it. These are a bit of work. Okay. Example 3. I feel like all my pens are running out. Example 3. So example 3 is going to be same directions. We're going to just do the same thing. Graph the following. Label the vertex and axis of symmetry. Okay. The standard form, we are going to do something a little different on this one at some point. Standard form is y equals 3x squared minus 3. I'm going to set up my graph real quick. I really recommend graph paper. Three, 6. All right. Got your axes. So A value is 3, B value is 0 again, and C value is negative 3. Make sure that negative goes with the value. So we're going to have B value of 0. So we're going to do the axis of symmetry. So the axis of symmetry, again, the formula is x equals negative b over 2a. Negative b over 2a. Don't forget the negative. So negative parentheses, the b value is 0 over 2 times a. The a value is 3. Negative 0 is 0 over 6 is 0. So the axis of symmetry is x equals 0. So I'm going to do that one a little different, just try and make it stand out. So a dashed line, it's a vertical line. It happens to be right on top of the y-axis. So AOS, axis symmetry. So we got that. We need the vertex. Now the vertex we get by plugging the axis symmetry x value into this function. Where we see x, you replace it with that. In parentheses now, 0 squared of 0 times 3 is 0, minus 3 is negative 3. So the vertex, the x value of the vertex is 0, the y value is negative 3. So the vertex is a point, is the x and y coordinate. So 0, negative 3, it is right here. This is your vertex. Next, we usually do the y-intercept. The y-intercept is easy. It is negative 3 because that's what the c value is, which happens to be right on top of the vertex. That's possible. Most of the time, vertex is not the y-intercept, but the y-intercept usually was another easy point to make our graphs quick, but it's not. It's the same point. So we need another point. Now, last time we did a table. This time, though, we could do we could find the x-intercepts. We could take the equation. So we could factor, I wrote this on the first page, factor to find x-intercepts or roots. So you take this equation, y equals 3x squared minus 3, and x-intercepts always happen when y is 0. So you plug a 0 in for the y, and then you factor it. So factoring, GCF, greatest common factor, you take 3 out. So we're dividing these out and multiplying them. Then we look for pairs here. And you might notice this is a special one because usually there was a term in the middle and it was a little more work. But this is going to be x and x, right? And 1 and 1. And one's going to be plus and one's going to be minus so that the middle term goes away. So now you factored it. So now we set each of these factors equal to 0. That's called the zero product property. And that should make this all go to 0. Should give us our x-intercept. So you solve each one on their own. You guys should remember doing this. We did it a lot. And you get your two x-intercepts. So our x-intercepts, we're going to have one right here at -1. They're on the x-axis. So that's an x-intercept. We have one right here. That's an x-intercept. And they're also a mirror image, which kind of makes sense too, right? And I think we have enough now to graph it, right? We got 3 points. I mean, you could get more points. And if you did the table, that would have given you those same points there. The last problem, the factoring, would not have worked well. This time it worked good. So there's your graph. We got a couple questions to answer. So we have the domain, which is all real numbers. Okay, so that's short for all real numbers. Meaning you can plug anything in for the x's. The range, usually not all real numbers for these guys. It's y is the smallest value is -3 and all the other y values above it. So it's greater than or equal to -3. Okay, and then we have the minimum. These, by the way, are x-intercepts. Minimum or maximum. So is the vertex the highest or lowest point of the graph? It is the lowest point of the graph. That's the lowest, smallest. It's the minimum, and the value is -3, the y value. It's the y value. So that's it. Your monitoring progress. Will be on page 432. Problems 1 through 9 all. They're all at the bottoms of the pages. If you do it on Student Dynamic ebook, they have little blue play button arrows next to them, and you play video that'll show you exactly how to do each problem, which might be good just to double check your answers, at least the first few or something, before you do them all wrong, and then do your homework wrong, and do your quiz wrong. Find out early on if you're doing right or wrong, and fix it if you're not. Okay, try it out. Ask me if you need some help.